So last class we were discussing about the list operations. We saw with how to find the length of the array elements by taking care of null. And then in iterative fashion as well as in linear iterative way as well as linear recursive way, we have written the procedures, and we have discussed it with an example, and we have seen when you have to traverse, the main highlight is when you have to traverse through the entire elements of the list, then we have to make use of the condition will be like it should be null till the last element has to be taken up. So with the condition what we use will be null. If suppose if you want only certain elements, then we will be taking it to be as we will not go ahead with the null condition. We will be taking up with respect to whatever constant value it is, like a counter or the length of what you have specified based on that. So keeping that here, the condition whatever we have given, it is like based on the count it is. So n is equals to 0. So it won't be null coming over here. And whenever we have to iterate, go through all the elements of the traverse through all the elements, then the other thing which we have to see is the selector part. We have to use the CDR to be as the selector. So those are the two things mainly when we have discussed about this one. We have stopped with this append part. So we have seen when we have to append two elements, that is the elements of two lists should be combined together. So for the first element, we have to traverse till the end of it. And the second element has to be, the second list should be combined with this, right? That is what is the meaning of the append. In the append, when we say append list 1 with list 2, that means that we have to traverse till the last element, because we don't know the length of your array. Length of the list is not known. So first we have to traverse through the entire elements of the list 1. And then we can directly, once you reach to the last element of the list 1, the next element will be null. That is, once you reach to the empty list of your list 1, then you can attach the list 2 with this. So how do you write the conditions? So the condition which you have to, when you are saying append list 1 with list 2, so we have to traverse complete elements till we reach the last element of the list, till we reach the nil of the list 1. So what do? We just give the condition to be as if the list 1 is an empty list. If so, then what we have to do? If that condition is satisfied, okay, let us see what we can do it. I just kept it as a blank here. Let us see if the condition is not true. If it is a condition is false. False means what we have to do? We have to keep calling the next. We have to take the first element of the list 1 and then keep on going. We have to take the next elements of the remaining elements of the list 1. So how we can make it? Still we want the output to be as a list format. So for getting the output to be in the list format, we can get it by using sequence of cons. So keeping that idea, what we have done is we can have cons given, cons of car of list 1, and again I will keep calling the append procedure with the remaining elements of the list 1. So like this I keep traversing till I reach the last element, that is till my list 1 becomes an empty list. Once my list 1 becomes an empty list, what I can give it back? If this condition is satisfied, I can directly give my list 2. My list 2 is nothing but it is cons of 5, cons of 6, cons of 7, which ends with nil. In other terms, I can say list 5, 6 and 7, right? So if this condition, once my list 1 reaches to an empty list, I can directly give it to be as list 2. I don't have to write any other things, because in my list 2, I know that there is a nil at the end. So I'm just making sure till I find the empty list of the list 1, I keep sequencing all the elements. So sequencing all the elements, that I can do it by using cons, sequence of cons. So cons of first element, which is 1. Again, I will call cons of 2. Again, append 3, 4 will go. List 2, I am not touching it. Again, it will go. So it goes on like this till what it will go? It will go till my list 1 reaches the empty list. Once I encounter the list 1 to be as an empty list, what I will do? I will directly return my list 2. So in my list 2, I have the last element to be as an empty list. So nil is there. So since I am saying it is a list, it will be nothing but again a sequence of cons. So indirectly I will get a single list, like how you are seeing the output here. So cons of 1, cons of 2, cons of 3, cons of 4. Till here it will be in the else part. Once it identifies the nil here, it will directly return the list 2. So when I say list 2, it is nothing but sequence of cons again. So cons of 5, cons of 6, cons of 7, nil. So indirectly it becomes a single list. Okay, let's see with that same example. So this is the procedure. So I'm just saying I have I am defining a variable called square with list 1, 4, 9, 16. So I can assign the list value either in this way, that is by using the output representation, or I can give the list elements saying list, or by using const terminology itself I can assign the values. So say define odds. Odds is a variable which is having list 1, 3 and 5. So I just made created a variable which has odd elements, 1, 3, 3 odd elements. And I have a square variable which has first 4 square elements. So 1, 4, 9 and 60. Now I am saying append the square variable elements with odd variable elements. So my list 1 is nothing but it is 1, 4, 9 and 16. List 2 is nothing but it is 1, 3 and 5. Right? So result, there is no such variable. I just maintained it. So first what happens? First I am calling append procedure with list 1 with 4 elements, list 2 with 3 elements. It checks whether my list 1 is an empty list. No. So it comes to the else part. In the else part, what it does cons of car of list 1. So which is nothing but it is 1. Again, I am calling the append procedure with my list 1 to be as 4, 9, 16. That is CDR part of it. So 4, 9, 16 will be my list 1 now. List 2 will remain same. Okay, that is my first iteration. The second iteration, again, I'm calling this append procedure. So again, it checks whether it is an empty list. So 4, 9, 16, it is not an empty list. So again, it comes to the else part where previously I had cons of 1. Again, I'm having cons of 4. Again, I'm calling the append procedure. With this append procedure, what happens? The new elements will be nothing but it will be CDR part of this 4, 9 and 16. So CDR part of 4, 9 and 16, it is 9 and 16. Again, list 2 will remain same. Again, it is not an empty list. List 1 is not an empty list. So again, sequence of cons. So cons of 1, cons of 4 is already there. Cons of 9, because car of this list 1, which is nothing but 9. So 9 will come over here. After that, append procedure is again getting called. What will be my list 1, updated list 1? It will be 16. And list 2 will remain same. Now again, list 1 is not an empty list. So again, it comes to the else part. Cons of car of 1, 4 and 9, which is already there. That is cons of 1, cons of 4, cons of 9. Now, again, since it is not an empty list, so cons of 16. Again, I'm calling the append procedure. Now, CDR of list 1 means, which is nothing but it is an empty list. List 2 will remain same. So now at this point of time, when the append procedure is getting called, what happens? The condition will be satisfied and it returns the list 2. So when I say list 2, indirectly I mean that it is cons of 1, cons of 3, cons of 5, nil. So in the result part, you can see there is no nil now. So now when I am returning the list 2, it will be attached with my already with the sequence of cons which I had kept, and for this you will be having a nil. So I am just creating by passing two lists. I am appending those two lists together. and you will be having nil at the end. Hope it is clear. Any doubt with respect to this append procedure?
No, ma'am.
Okay. Have two exercise questions. So you are asked to define a procedure. The name of the procedure should be last pair. What you are expected? By using this last pair, you are expected to return the list that contains the last element. Okay. So for example, like if your last pair is the name of the procedure, and if your argument, if your values, what you are going to pass is list 23, 72, 149, 34. What you have to return is, it should return list 34. So how do you define the procedure? I didn't define the procedure here. Can you define it? So we can define the procedure.
It's just doing CDR, CDR, CDR and giving the CAR towards the end, ma'am. Like we will be maintaining some count or something like that.
Ma'am,
Count is required? Yes.
ma'am, we can do like null question mark, null question mark CDR of list. If that is true, then return CAR of list.
CAR of list. Yes. So last pair, like this, what you have said. So I'm saying it to be as L1. As my screen, whatever I'm typing, is it visible? Just increase the size. So if only one condition we have, and we have to go on till null. Yeah. Vishnu, you are telling something. If null.
Null question mark CDR of this list
CDR of
L1.
L1. Yeah,
L1.
list one. Closing the null condition.
If this condition satisfied, then return CAR of L1.
R of L1.
Else, then else part will be uh, like go skip the first one, CDR of L1.
We
Call
don't
the
have
function
any of the first elements. So I can directly call this last pair procedure
with CDR
just
of.
by reducing the list elements. So L1. So last pair is closed. If is closed, define is closed. Will this be fine? So first I'm checking whether, so take the same example, 23, 72, 149, 34. So my first element is 23. Car of this list means 23. CDR means it will be 72, 149, 34. So it is not an empty list. So it will come to the else pair, else condition. It will again call. So 72, 149, 34 will be passed. Again, we are taking the CDR part. So 149 and 34, it is not an empty list. So again, it comes to the else part. Reduce it. So it will be 149, 34. When you are saying 149, 34, you are checking if null CDR part. So you will be having 34 there. So it is not an empty list. Again, come to the else part. In the else part, what you are having? Are you able to visualize it? Or I'll just keep it here. I'll just write here. First time it is list 20, 23, 72, 149, 34. After that, for this, there is no empty list. So CDR we have reduced. So 72, 149 and 34. Next again reduced. Again call the last pair procedure where it will be 149 and 34. Now, when we are here, if null of CDR, so CDR of this list means it is 34. It is not an empty list. Again, it will come. It will call the last pair procedure where it will be passing CDR of this list. So CDR of this list means which is list 34. So now when you check if null of CDR, so for this list, car is 34, CDR is an empty list. Condition will be satisfied. So now when you are saying car of L1, so when I say car of L1, what do I get from this list? What do I get from this list if I apply car?
34.
It will be 34. But what is expected? It is list 34. Right? I don't want a value 34. I want list 34. So you see in the question itself, define a procedure last pair that returns the list. Okay, they don't want the value. They want the list itself. So last element content along with the nil. So what we have to return here?
Return L1.
Be car. It should be only L1. Okay. So whatever is your L1, so your L1 is list 34 along with the empty list. So then only you can directly return that L1. Is it clear? So when you are seeing the questions, you can see like what is expected. So return the list. List means you are expected to have the elements in the list form itself. That is with the brackets itself. Otherwise, they will say it will be like with the value. So what it is, you have to clearly understand. So keeping this will be the procedure which will be for this question. Okay. So I'll just keep it in some other font. Okay. Moving on to the next one. So define a procedure reverse that takes a list as an argument and returns a list of the same elements in reverse order. How do you do this? Very busy chatting. Okay, so now you are asked to define a procedure named reverse that takes list as an argument. And here you are expected to return a list itself. In what form? It should be in the reverse form. So in the example, if you see, if you are calling the reverse procedure with the list element to be as 1, 4, 9, 16, 25, your expected output is opposite. So 25, 16, 9, 4, 1, close the brackets. So how do you define the procedure here now? So define. Name of the procedure reverse. So define reverse. How many arguments do we have here for this procedure?
Only the list.
Only the list. Okay. So one single argument. Now, what should happen for this?
Ma'am, I have a logic. I don't know if it's correct. Shall I tell that, ma'am?
Yes, yes, yes.
Ma'am, like we'll have to use cons in reverse order. Like take the car of the list, put that as the second element, and then call this reverse function again with the CDR of the list with as the first argument.
Yeah,
Con something like
straight
that.
out. Yeah. So what will be the condition? Anyways, one condition is required. So what condition
Un-
you will have?
until it
None.
reaches null.
Until it reaches none. So L1. So after this, if it is satisfied,
Return. Okay, wait. Return empty. There's nothing to do. Like
nothing to do.
yeah,
So
if it is not null, we'll have to do.
blank, right? In this place, we
Ma'am,
can't leave it.
instead we can put a null question mark CDR of L1 and we can return L1 itself.
Okay. So L1, CDR of L1 and return L1. Okay. If condition doesn't satisfy,
Now cons of cons of reverse, like that that's the first parameter, reverse of CDR of L1.
CDR of L1, close the reverse. Second
And
part of cons will be
cons will be car of L1.
R of L1. Done.
Yes.
Cons closed. If closed, define closed.
There should be a nil also.
Let's analyze it. This is the procedure given. So let's take a smaller contents. So let's go with 3 elements. So this is the input what I'm giving it. So initially when I'm calling reverse procedure, my list is 1, 4 and 9. So it's CDR part of L1 means which is 4, 9. It is not an empty list. It comes to the else part. So cons of, I'm calling the reverse procedure. So REV I'll write CDR part of this list. So it will be 4 and 9 closing. Car of this list, it will be 1. Done. Right. Now again expansion. So cons reverse procedure I'm calling CDR part of 4, 9. CDR part of 4, 9 means which is 9 all alone. It is not an empty list. So again it comes to the sequence cons of. Again I will call the reverse procedure where CDR part of this it will be list 9. Okay, I've closed reverse. Yeah, I have closed reverse. The second part of it will be the car of this 4, 9. It will be value 4. Close this inner cons. Outer cons is getting closed. Done. Now once again cons of yeah. Now when you see, now when I see, it will be cons of. So now we are calling this procedure reverse procedure with list to be as 9. So now you see CDR part of list 9 means which is an empty list. So I am directly returning L1. Right? L1 means which is nothing but it will be 9 followed by nil. Agree?
Yes, ma'am. So it should be car of L1.
So it should be
Car of L1. We only need 9, no, ma'am.
okay, car of L1. So if I change this car of L1. So now what will happen? You're just returning value 9. Right? Then comes 4. Then there was 1. So how your output will be for this? Your output for this will be cons of cons of 9, 4, 1. So how the output representation for this will be? You can just draw the box point representation and you can just see how it will come.
Ma'am, it won't be list, ma'am. It'll be bracket 9.4, then 1.
It will be bracket 9.4 dot 1 dot 4 dot 1. But our expected one is this. Got it? So this logic, so usually when we take up for this question, mostly everyone will give this logic, but this logic will not work out for this. Now think. Now what should we do? And one more thing is there. Our cons is going inner and inner. Okay. And now if you say, okay, let's say you are checking for L1. Okay, let list be this one. Till then you keep going, and once you reach to the empty list, once your list 1 becomes an empty list, you are just returning nil itself, an empty nil itself. If that is the case, now what happens? Then will we get the answer? Just think. If you have to return an empty list, either you can return the empty list with the keyword nil, or you can use the same or this representation. Single quote, open bracket, close bracket. The same output, how do you get? That same representation you can use. Either you can use the keyword nil, or you can use this output representation. I think the recent interpreters are not identifying this nil. Instead, they are identifying the null itself. So you can try out this, or you can even try out this null. Instead of nil, they have redefined it to be as null itself. So you can just try out for either of these three cases when you are using the racket. Okay. So in textbooks and all, you will be finding these two cases. Okay, now let us analyze. Now what will be the situation? So we have reached till here. Reverse of 9 we are calling. List 1 is nothing but 9. So it is not an empty list. So again you will reach to the else part. So where you will have cons of. Again you will call the reverse procedure with CDR part of it. So CDR part of it means which is nothing but an empty list. Now closing the reverse question part. Now cons of this list, that is car of this list means which is nothing but it will be 9. Close this, then comes 4, then comes 1. Now what happens? Now we will have cons. Now we are calling this reverse procedure with an empty list. So when we are returning, when we call this empty list, what happens? It is just returning nil itself. So cons of nil, then comes 9, then comes 4, then comes 1. This is also not correct, right? So starting point itself, you are saying this is my end of it. So it will not even display 9, 4, 1. It will directly give you the output to be as an empty list. So this is not the correct representation for our list. So you are getting my point?
Ma'am, why this is wrong?
Why it is wrong? Because cons of nil itself. You just draw the box and see. If you just draw the box, how it will be? Box point representation. It will be, this is my starting of my pointer, box pointer representation. So it is, so cons of my first cons, Oh, one second. So cons of my first part will be again another cons. So which will be, so cons of this one. This is having the value, this cons is having the value 1. This cons is having the value 4, right? As per the output, whatever we got, this is a nil and this is our 9, right? So when we go down, so when it starts displaying the contents, what you will have initially itself, you are saying it's a nil, it's end. I don't have anything. When we say nil, what does that mean? It is like this is the end of it, right? I don't have any more contents after this. So why should it go and see the remaining contents? It will not see. And the output what you will be getting also will be in the wrong format. It will not give you a list itself. Okay, so this is not the logic. So now what should we do now? So what should be the modification, what we have to do here? So by using cons, if you do it, we always remember the nil when we have to get it to be a set list, the nil should be at the end of it. So that means after 1, you should get the nil. How can we make it?
Ma'am, can we use 2 parameters, ma'am? What we can do is, here we are only passing L1, no, ma'am. We'll take one more called L2. If null question mark L1, then we'll return L2. If it's not null, in this case is cons of reverse CADR and cons of reverse CADR and car of L1. CADR of L1 and car of L1.
So then also the situation will be same, right?
No, ma'am. No, ma'am. Example, you take 149, ma'am. When we'll first take 149, no, 9. The reverse of this is 941. We'll take two pairs and we'll keep reversing them simultaneously. We'll take 1 and 4. So CADR will return 4, and then we'll do that. We'll do cons of that. We'll get 4 and 1, and then second time 4. We'll add 4 and 1, and then we'll do car with whatever is remaining. That time we'll get 9-4. So everything will be in L2. 941 will get.
Yeah, but you are using sequence of cons only, right? The sequence of cons, but
Ma'am, for
Like
that we can use list only, ma'am, instead of cons.
list if you use, it will become another way. Instead, what you can do is tell them.
After in the second part, in the else part, instead of cons reverse this one, can we use cons of reverse this thing? The first part stays, and then one more cons of car of L1 and nil. The second parameter will be cons of car L1 and null or nil. Which one?
Oh, 1 second. I think I drew the box point representation wrong right before. I just drew down. Yeah, it is wrong. It should come in a sequential way, right? Yeah, I drew it wrong. Yeah. Before, when I drew the cons of, did I draw correct or wrong? It was correct only. It was correct. Sorry, I got confused. It was correct only. Yeah. Yes. You were telling Vishnu. You were telling cons of car of L1 followed by nil here.
Yes,
right?
Yes.
Then also the situation remains same, right?
Ma'am, but every time the cons of L1 and nil will return, like the resultant will be a list with only. Okay, yeah. Yes, ma'am.
Still the
Got it.
situation is same. Yeah.
So,
What you said, everything is one small place, if you do the modification, whatever you have told right now, we can we will be able to get the reverse elements. The thing is, what you have said, this cons car of L1 and nil, let it stay as such. Here, instead of this cons, why don't we try with append? What happens if it is, see, append, this will be our first argument. That is list 1. This will become our second argument. So what happens? Once my reverse is going to return nil, it is going to append everything. So you will not get this nil at the beginning. You will automatically push it to the backward. Just try analyzing it. This cons of car1 and nil, let it, that will be same. Indirectly, I can say this to be as, instead of saying like this, I can say like this is, instead of cons, I will say it to be as list. Done. So when I use the terminology list, automatically nil will be at the end. Right? So now what happens? If my L1 is an empty list, it will return an empty list itself. Otherwise, I will call the append procedure. Append procedure. First, it is not directly returning the list. I'm calling the reverse procedure. Reverse procedure with, due to space constraint, I'm reducing the name of the procedure names. I'm just reducing it. Reverse CDR of L1. So CDR of L1, which will be 4 and 9. With the reverse part, here I will be having list 1. Done. Next again, append will be carried. Append will be there as such. APP I will write. Now I'm expanding this reverse procedure. So when I'm expanding this reverse procedure, it checks whether it is an empty list. It's not an empty list. So again, it comes to the else part. Append. Again, I'm calling the reverse procedure with CDR part of it. So CDR part of it, it will be nothing but 9. The second part of the list 2 for this append will be nothing but list bracket, I forgot. So list 4. Closing of the append, I'll put a tab here and give list 1. Now append will come as such. Before append will come as such. Now I am expanding this reverse procedure. This is also not an empty list. So again, append. I'm calling the reverse procedure now. Now it will be an empty list. And the second part of it, it will be list of 9. Closing the append, I'll just give little space. List of 4. List of 4. I'll just give a space. List of 1. Here one more bracket is required because this append I have to close here. Then next one I have opened list 1. Now what happens? Append is there as such. Next append is there as such. This append is there. Now once the reverse is going to, it's an empty list. I'm just returning it to be as an nil. Nil means which is nothing but it is output representation itself I'll give. Now it is list and list 9. Close the append. List 4. Close the second append. Then comes list 1. Close the next append. Now what will happen? Append. So appending an empty list with 9. What will be my output here? Once I append,
list 9.
it will be list 9 itself. So I can say for this output, it will be list 9. Done. So which will be list 4 closed. Next it will be list 1 closed. We append. So when I append list 9 with list 4, my output will be list 9 and 4. Second argument is list 1. Now when I append 9, 4 and list 1, my output will be list 9, 4 and 1. Is it clear? So it is better. We will not get the output by using cons. For reverse, we have to use append, not cons. Okay. And we have to make sure we can't simply give car of L1, because when we say car of L1, it will be single data. That we have to make it to be as a list. So for making it to be as a list, we have written it to be as list of car 1. Closure of the brackets we have to see. So this one, list is closed, append is closed, if is closed, define should be closed. Okay. So the point here, the highlight what you have to analyze here is when to use cons, when to use list, when to use append. So these are the 3 things which you have to understand from this procedure, from this logic. So when we are using cons, you have to make sure the nil will be at the end of it. Then only you will be able to get a list. If it is coming at the beginning itself, then you will not be able to get the proper output. That is, you are saying that I'm stopping it here itself. So that is not possible. Next thing is when you use list, you will be getting you have already seen how the box pointer representation it is and how the output how we are getting it. So you will not get as a single list. You will be getting multiple lists. That is list inside a list. It will be like a hierarchy. So to avoid everything and if you want to make it to be as a single list, then better to go with append itself. So to make use of this append for this reverse procedure, only one thing which we have to take care is we have to make the second argument as an explicitly we are making it to be as a list. That is the thing which we have to take care. Okay. So I will just remove this portion and I will leave the definition of the procedure. Okay. So we shall move. Next is mapping over list. What's the time?
11:53, ma'am.
Okay, I'll stop with this. I'll continue with this mapping over list in the next class. Before stopping, I'll just let you know what is the exam pattern, how it will be. Okay, so exam for SCIP, you are having the exam on 7th, that is on Tuesday. Timings? Anyone of you remember the timings?
Afternoon, 2 o'clock.
Afternoon 2 o'clock. See, this time exams are not at the same time. All of you see the timings and the date. You have next week you have 3 exams and each exam is at different timings. See the timings and join for the exam on time. And the remaining 2 exams on the next week, 13th and 14th. Those 2 exams are on the same time, I think, right? 1 o'clock to 2 o'clock.
Yes, ma'am.
Yeah, so see the timings and join for the exam without fail. Yeah, coming to the exam pattern. Exam pattern, you will be getting the questions with respect to fill in the blanks, multiple choice questions, and one upload question will be there. Okay, so keep paper and pen, A4 size paper, you keep it ready before your exam itself. Write your name, register number, class, this section, and subject name, subject code. So keep this ready before day itself. You will have 1 or 2 questions for uploading for uploading purpose. That is 1 or 2 questions you have to write it, and you have to upload it only once. That is like you have to make it to be as a single PDF and you have to upload it. Okay, so this is the pattern. Exam is for 30 marks. You will find the exam in tests and quizzes. Exam will be for 1 hour. Okay.
Ma'am?
Yeah.
Is that one upload question confirmed? Like we need to submit in the EMS itself, ma'am?
That we will let you know on the day of exam where you have to upload. But upload question will be there.
Okay, ma'am.
Where to upload, I'll let you know later. But you just keep your pen and paper, everything ready before the exam. Okay.
Syllabus, ma'am.
Syllabus till last class. That is till Tuesday what we have taken. So Tuesday till what we have taken, it is till this one. Yeah, list operations. List operations, car, CDR, these things. Making the list till here you will be having for your midterm from starting. Complete chapter 1 and chapter 2 till here. Representing the sequence. Okay. So in chapter 1, we discussed about the basic syntax of the Lisp language, the list programming, and then we looked into the substitution model, applicative and normal order, and then we discussed about how do we define a procedure. After defining the procedure, applicative and normal order, and then we have seen when we define the procedure in different ways, what type of process we achieve, like linear iterative, linear recursive, tree recursive process, and based on that, what is the order of growth we have seen. So for each topics, we had some applications like square root procedure and some exponentiation procedure, something like that, GCD, prime number, all these were the applications. After that, we discussed about defining the procedure without giving any name, that is by using lambda and let. What was the syntax? How do we use it? And when we are defining the procedure, we can pass it as an arguments, how it can be passed as an arguments, as well as how it can be made to be as a return type. So higher order procedures we discussed. So that is the end of the first chapter. As an application for higher order procedures, we discussed about fixed point, function and midpoint, finding the midpoint, and that is about the first chapter. Coming to the second chapter, we started seeing about the data, abstraction in data. So how this cons has been used for construction. Then selectors, car and CDR. Then as an application for that, we have seen the rational number procedure. And then coming to the sequence of cons, there is nothing but list. So when do you use list, how it is, and how the selectors could be used. So when you are using the selectors, how the data values you could retrieve. And then, yeah, that's it. So, and then we discuss the 2 procedures based on.
Ma'am, here till which slide, ma'am? Last slide number, please.
Till here, slide number 60.
Okay.
I'll upload this hierarchical data. Rest all slides are there, I think, already uploaded. This I'll upload it today. Okay, then thank you. So thank you for your patience.